Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today we'll be solving the problem LeetCode number 15, 3 sum. So the problem statement says that given an integer array nums, return all the triplets nums of I, j and k such that all the three I, j and k are not equal, they all are different and this sum to 0 and we have to find all the triplets unique. All right, so the problem statement just says that we are given a nums array and we have to just find triplets. All right, we have to find triplets such that they sum to 0 and we have to just store those triplets into an array and return that array such that they sum to 0. So in this case we can find two triplets, that is -1 and 2 and -1 0 1. These both triplets sum to 0. No matter what's their order, we have to just find triplets and unique triplets. All right, so how we can find this? We are given nums array as an input. Let me take an example. So taking this example only, example 1, -1 0 1. So -1 0 1, 2 -1 -4, 2 -1 -4. Now I have this array. Now I have to find triplets. All right, so what I will do, first of all I will sort it and I will tell you why I sorted it. So after sorting it, this will become -4 -1 -1 0 1 and 2. Now after sorting it, first I will be here, I will use three pointers because I have to find triplets. All right, so my I will be here at first and j will be at I plus 1 and k will be, the third pointer will be at last. Now first of all what I will do, I can see my array is sorted. Now I will find the sum. What is the current sum with these pointers? So the sum is -4 -1, that is -5, -5 plus 2, that is -3. And we can see we need to find the sum equal to 0, but this is less than 0. So what I did, I just fixed my I pointer right now. All right, and now I have this window j and k and I have to just move j and k. My I is fixed and I have to move j and k and we can see the array is sorted. So where should I move j or k? What should I move, j or k? J forward or k backward, such that my sum can be closer to 0. So we can see -3 is less than 0 and we need some greater. All right, so I think we should move j forward so that our sum can be increased. So now in this case our sum is -4 -1 and 2. Again we can see our sum is again -3. Now again we will move j. Now we can see our sum is -2, which is again less than 0. So what I will do, I will again move j. So my sum again -1, which is less than 0. So I will again move j. So j will now be at k, but j and k, all pointers should be different at the different positions. So I will stop here. Now I will say this iteration is completed. Now I will move my I pointer ahead. Now my I pointer will be here. Now I have fixed my I pointer and my j pointer will be at I plus 1 and k pointer will be at the last. Now my window is this. My I pointer is fixed now and now I have to find two values such that they sum to 0. So we can see that these are sorted. Now the sum is what? minus 1 and 2. Minus 1 plus minus 1 minus 1 minus 2 and this 2. This the sum is equal to now 0. So what I will say that I will add this triplet. We have found a triplet minus 1 and 2, and I will add this into my, let's say, answer or result. Alright, now again, if we have found successfully a triplet, now I will move both j and k pointers. Now the sum is minus 1, 0 and plus 1. So we can see again we have found sum equal to 0. I will add this to my resultant array. So this will be minus 1, 0 and 1. Again I will move j and k, but this time they will cross them. So there is no need to check now because they have crossed. Now we are done with this iteration. Now what I will do, I will just again move my I pointer ahead. This way the here I pointer will be at this position. Alright, now I can say that my j and k are now fixed. Now I will find sum. So the sum is currently minus 1, 0, 2, which is plus 1. We can see that sum is greater than 0. In this case we have to reduce our sum. So our array is sorted. If we move k backward, our sum will reduce. So now the sum is coming minus 1, 0 and 1. So this way we can see we have found a triplet, but we can see that we already have this triplet in our resultant array. So why this triplet again came? Because we didn't skipped the same values minus 1. So if what I will do, if our nums of I was equal to nums of I minus 1, I will skip it. So in this case I should have skipped it. Then I would not have got the same triplet. So I should have skipped it. Now after knowing it, I should have skipped it. Now I will move my again pointers. I will be here and j and k will be fixed. Now the sum is 0, 1 and 2, that is 3, and this time sum is very far greater than 0. So I should reduce my k pointer, but they both are equal. This is not a valid case. So I will say that this case is now over. Alright, so now again I will move I pointer again. I will be here. Now my j will be at I plus 1 and k will be at the last again here. So again we are at the same position. I will skip it. Now I will be at the last. Alright, now j will be at I plus 1. This will go out of bound. Alright, nothing. So we will skip this also. Now our I will be also moving and this will go out of bound. Now our iteration will be completed, and now we can see in the resultant array we have two triplets, minus 1 and 2, minus 1 and 2, minus 1, 0, 1, minus 1, 0, 1. So yes, we have now created our logic that first of all we have to sort the array, and then we have to fix a pointer here, and we need to find triplets. So we will fix a pointer here, and we will try to find two pointers here anyhow, because we have the array sorted, so we can easily find by moving j and k. Alright, so again I will be here. We will check all the possibilities here. So this way we can check our the sum of the three pointers values is equal to target sum or not. So if I implement this, so first of all I have to return a resultant array. So I will store the resultant array, let's say a result, and now what I said, That's first of all I have to sort the array. So first of all, without wasting any time, I will just sort it. Nums dot end. Now what I will do, I have to keep moving my I pointer from the starting to the end. So now what I said, that I will skip the I pointers if I find any duplicate, I will skip it. So if nums of I and I is greater than 0, that edge case, if nums of I equals to nums of I minus 1, then continue. Else I will declare two pointers. J will be at I plus 1 and k will be at the last. And what is n? N is nothing but size of nums array. Now while j is less than k, alright, so I will check sum. So first of all, let me check that what can be the values. So 10 to the power 5 is the value, and at max, if all the values are 10 to the power 5, 3 into 10 to the power 5, 3 into 10 to the power 5, and they will be in this integer range. So I will say sum will be equal to nums of I plus nums of j plus nums of k. Now I will check. Three cases will be there, we all know. Sum will be equal to 0, sum will be less than 0, or sum will be greater than 0. So if sum will be equal to 0, we will store the triplet in the resultant array. So what we have to store? The values. So nums of I comma nums of j comma nums of k. Alright, and now here we have to move both j and k pointers. Now after moving j and k pointers, I should skip also. Alright, suppose we have found minus 1 and 2. Suppose we have found this. On now we are moving j and k forward and backward respectively. So we should skip the duplicates also. This is optional, but this will save our time complexity. Alright, so, and time complexity it will save, and also duplicates also. So this is very important. Alright, so we should always handle the duplicate cases. So I will say while j is less than k, keep moving j, nums of j, if nums of j is equals to nums of j minus 1, so keep moving j. Alright, similarly while j is less than k and nums of k, if it is equals to nums of k plus 1, keep moving k value. Alright, and if sum is less than 0, alright, so if sum is less than 0, what we have to do, if sum is less than 0, we have to increase our sum. So we will move j forward, and if sum is less than 0, we have to increase our sum. And in the else case, if sum is greater than 0, we have to reduce. So we will move k. And here also I would like to handle the duplicate cases, because it will save our time complexity and save us from the duplicates also. So now after running all this, my resultant array will be ready, and now I will just return resultant array. Now I will just run the sample test cases and check if we are able to pass all the test cases, and if I submit this and check if we are able to pass all the test cases or not. So yes, we are able to pass all the test cases and we have solved this problem successfully. And if I tell you the time and space complexity, So we can see that we are running a for loop, and inside we are using two pointers also, so the two pointers are also running inside. So the time complexity at max, in the worst case, it can be big of n square. All right. And space complexity, we can say that are we taking any space? Are we taking any space? No, we are not taking. So space complexity is big of 1. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.